Imagine a force so powerful that it can accelerate particles to nearly the speed of light and send them hurtling across the solar system. This isn't science fiction. It's our sun, and scientists have just cracked one of its most intriguing mysteries. Thanks to groundbreaking observations from the ESA's solar orbiter, we now understand how the sun generates streams of high-speed electrons, shedding light on two distinct types of these phenomena. But here's where it gets fascinating. Not all of these energetic particles behave the same way, and their origins are as diverse as they are explosive. The sun, often described as the ultimate particle accelerator in our cosmic neighborhood, propels electrons at astonishing velocities into space. These electrons, known as solar energetic electrons, SEEs, fill the solar system with charged particles that can impact everything from satellite operations to space weather forecasts. What's remarkable is that researchers have traced these electrons back to their exact birthplaces on the sun, revealing two primary sources: sudden bursts triggered by solar flares, and prolonged waves unleashed by massive eruptions called coronal mass ejections, CMEs. Think of it like this, says lead author Alexander Warmoth of the Leibniz Institute for Astrophysics Potsdam, AIP in Germany. There are impulsive events, where electrons rocket off the sun's surface in short, intense bursts during solar flares. Then there are gradual events, which are more like slow-moving tsunamis of particles, released over hours or even days by CMEs. This distinction wasn't always clear, but thanks to solar orbiters' unprecedented proximity to the sun, scientists were finally able to observe hundreds of SEE events up close and piece together their origins. And this is the part most people miss. Solar Orbiter didn't just provide snapshots of these events. It offered a dynamic, multi-instrument view. By flying closer to the sun than any previous mission, the spacecraft captured these particles in their earliest, pristine state. This allowed researchers to pinpoint exactly when and where the electrons began their journey. Over 3 years, from November 2020 to December 2022, the spacecraft observed more than 300 SEE events, using 8 of its 10 onboard instruments. The result? A comprehensive catalog that will serve as a foundation for future studies. But why does this matter? For decades, astronomers noticed something puzzling. When they detected solar flares or CMEs, there was often a delay between the event itself and the arrival of the associated energetic electrons. Why did some particles take longer to escape? The answer lies in the turbulent environment of interplanetary space. As co-author Laura Rodriguez Garcia explains, these electrons don't travel in straight lines. They encounter turbulence, magnetic fields, and other obstacles that scatter them in different directions. The farther you move from the sun, the more pronounced these effects become. This turbulence is caused by the solar wind, a constant stream of charged particles flowing outward from the sun, and the magnetic fields it drags along. Together, they create a chaotic medium through which SEEs must navigate. Understanding this process is crucial for predicting space weather, especially since CME-related SEEs pose a greater threat due to their higher energy levels and potential to damage satellites, disrupt communications, and endanger astronauts. The implications of this research extend beyond pure science. According to Daniel Mueller, ESA project scientist for Solar Orbiter, by better understanding these particles, we're equipping ourselves to protect both current and future missions in space. It's a shining example of what international collaboration can achieve. Indeed, the study brought together experts from across Europe, the United States, and beyond, showcasing the power of teamwork in unraveling cosmic mysteries. Looking ahead, the quest to understand our star continues with upcoming missions like ESA's Vigil, set to launch in 2031. Vigil will monitor the sun's far side, providing early warnings of potentially hazardous solar activity before it rotates into Earth's view. Meanwhile, next year's SMILE mission will delve deeper into how Earth interacts with the solar wind and shields itself from harmful particles. So, what do you think? Is the sun a benevolent giver of life, or a tempestuous force to be reckoned with? As technology advances and our knowledge grows, one thing is certain. The sun still holds many secrets waiting to be uncovered. Share your thoughts in the comments below.